Welcome to More Living with Jim Brogan, your source of information for living the best years of your life your way. For more than a decade, host Jim Brogan and his expert guests have come together each week to share important news and advice that can impact the lives and well-being of those who are retired and those nearing retirement. Learn about issues like health and fitness, financial planning, social security benefits, investment advice, and more. And now, here's the host of More Living, Jim Brogan.
Good morning, East Tennessee, and welcome to More Living with Jim Brogan, where it's all about living the best years of your life your way. This is News Talk 98.7 WOKI. And you know, I know it's easy to get caught up in on this earth we live on, and our community and day-to-day life, and especially in 2020 with all the crazy things that have been going on. But, you know, we live in a big world, and I know for me personally, over the last 5 or 6 years, it just amazes me when I look up at the sky and I study, we look at the stars and we study, rocks and the origins of the earth and the world. And it's just amazing when you see what I believe is God's creation and how it all came together. And since the invention of space travel, scientists have been hoping to take their studies to other planets in our solar system. And the search for how life, is there other life in other areas other than just on the Earth? Has there ever been any life of any kind, even in our solar system? So it's been a passion for many, including our guest this morning, who is very, very involved in what NASA's doing and science is doing with going to Mars. And so Dr. Linda Kai is a geologist and associate professor at the University of Tennessee's Department of Earth and Planetary Sciences, where she teaches students about the evolution of the Earth's biosphere. And in addition to Earth-based research projects, she is the co-investigator on the Mars Science Laboratory mission, which was just recently launched, investigating potential habitable environments on Mars. So we're just absolutely thrilled, Dr. Kai, to have you on the show. Welcome.
Hi, how are you this morning?
I'm doing fantastic. Dr. Kai, before we get too much into Mars, fossils, rocks, and dirt are the passion of a geologist. So have you always been interested in rocks? What brought you on your path to where you are now?
I have to admit that I always have been. It truly has been my life. In fact, I told my kindergarten teacher that I wanted to either be a geologist, an archaeologist, or a truck driver.
Oh my goodness!
So by the age of 5, I was pretty well set, and I think this was because I was lucky enough to grow up in nature and exploring nature, and we'd always go hiking in the woods, and we would pick up and collect things. And there was the rule in my household that if you picked it up, you carried it, because that way my mom could avoid her kids picking up too much crap. But it has always been part of my life, and I think I was about 9 years old when my family went on a vacation out to Utah, out to the Canyonlands. And I saw, for the first time, I grew up in Ohio, so a nice vegetated area. This trip to Utah was the first time that I got to see, rocks without vegetation and these towering cliffs and orange and red colors against the blue of the sky. And everything about it was astounding. I mean, it was almost an artistic love of what I was seeing. And so when I went to college, there really was no other option for me. My father tried to stop that. It was, mid-'80s, and the oil companies had just fired everybody. And so my dad was like, do something else. And no, I tried. One semester I studied physics, and no, I was a geologist.
Well, it just got in your blood at an early age, right? And then at what point when you were getting all into that, did you become interested in, hey, what can we learn about these rocks from the origins of the Earth?
Yeah, and that was really, I was always fascinated with how the Earth got to where it is now. What is the pathway that the Earth took? And I'm always one for challenges. When I was leaving undergraduate and going to graduate school, I was actually really lucky. I worked with two fabulous scientists. And my undergraduate advisor, a man named John Grotzinger, he now teaches out at Caltech, he studied some of the Earth's oldest sedimentary rocks, so the oldest rocks that were formed at the surface of the Earth. And he was actually looking for reasons to collaborate with another scientist named Andy Knoll, who teaches at Harvard. And I think I was part of a peace treaty, two senior scientists wanting to work to each other and saying, hey, I'll send you one of my good undergrads. But so I traveled and I met Andy, and he worked on, again, old rocks, but substantially younger. And these were two guys that were telling the first story we had of the early parts of the Earth. And I pointed out that between their two data points, there was 1 billion years. 1 billion. It's a huge number. And so I immediately jumped into working at a time period that nobody had really looked at before. And it's actually frequently called the boring billion, which I've been fighting for 20 years because it's absolutely fascinating and not boring. And so I started looking at how the Earth changed between when we had our first photosynthetic microbes to where we had animals, and all of the different steps that needed to be taken in the pathway of Earth to get there.
There are so many things I could ask you about that. I'd love to go, maybe we need to do another show about Earth and about the different philosophies and what science says. And but I do want to get into Mars. I feel like we could have a whole show just about Earth. It's just so fascinating. And I actually love to just, the study of astronomy and what we can learn from astronomy has been fascinating too. But I don't want to get too off the beaten path here. We have you on to talk mainly about Mars. So let's dive into that. You're part of this incredible project with the Mars Science Laboratory. So tell our listeners about this project.
Yeah, so there's actually two projects, if you don't mind a little bit of correction. There's actually two projects. The Mars Science Laboratory mission is actually already on Mars, and it has been for about 8 years. And I'm a part of that mission. That's what actually brought me into Mars. The one that just launched, we call the Mars 2020 mission, or the Perseverance rover. So the Mars Science Laboratory is the Curiosity rover. Mars 2020 is the Perseverance rover. But I'm involved in both of these, and it's actually a wonderful mix of missions, because the Mars Curiosity rover, the one that's been on Mars for 8 years, was both a very innovative rover. We brought technology, laboratory technologies that had never before been on a mission to Mars. And it's essentially a mobile laboratory. It's really, really an amazing machine. But its mission was very similar to past missions of Mars. And when we think about habitability, about whether or not there might be life elsewhere in the universe, elsewhere in our solar system, we typically think of three things, because all life needs chemistry, they need nutrients, they need a source of energy, and they need a fluid, and a fluid in which all of the chemistry of life can happen. And the most common fluid for that is water. And so NASA for years has had sort of a mantra, follow the water, follow the water. If we can find water, we can find places that potentially could have been habitable. And the Curiosity rover sort of follows that pathway, with the addition that they have chemistry to actually look for the nutrients and energy sources as well. The Mars 2020 mission, which just launched, is a whole new generation, because this is actually the first of a 3-mission sequence where we're actually going to be collecting materials that we will bring back to Earth. It is a sample return mission. And as a sample return mission, with the object of finding sort of a life discovery mission. Can we find that life was actually there? And this is the whole big next step. I mean, right now on Earth, The only rocks we get to study from Mars are any meteorites that have landed here, that have been blown off the surface of Mars, traveled through space, and then come through our own atmosphere and been modified. And so they're not the best option. But we have a coring machine, and we're going to be making little drill cores, packaging them up, and then 2 future missions will collect those and bring them back to Earth. And that is, to me, astounding and spectacular, because as a geologist, yes, I know that 10 minutes with a microscope and a real rock in my hand will change the way we think about Mars.
Yeah, I mean, it's just amazing to think about. And I know there's a canyon there, and what looks like, from what I've been reading, you can correct me when we come back from our break, but what looked like could have been waterbeds feeding into that area. But before we get to the break, I do want to ask you, and then we'll come back and talk more about this Mars mission, but you were quoted as saying that space is the only part of science you've never really found interesting, and now you've been involved in this Mars project. How ironic is that? And what are is that, can you believe you're where you are now with what you said in the past?
Well, the thing is, I can actually still say that now, and I'm afraid probably my bosses won't like me saying that, but there's a lot of people that work in planetary science. A friend of mine described it to me once as they're all the people that realized, that they couldn't actually go to, Star Trek Academy, that thing didn't exist yet. And there seems to be something genetic in them to reach out to space and to reach out to space. I don't have that gene. I don't know why, but I don't have that. But there is, so it's not that I'm working in space that excites me. What excites me is that I have another opportunity to search out where life might exist and how that record is recorded in rocks. And so to me, it's a different field area. But I think also, I've done field work in the Sahara, in Russia, in China, in India. So I've been all these places. So it's another place for me. You've been in the Canadian Arctic, the Sierra Desert, the Andes Mountains. You've just been able to study things everywhere, right? Yeah, and it's been fabulous. Yeah, I love incredible. Traveling. Tell you what, we're going to get to our break, and when we come back, we're going to dive more into when this mission was launched, what are other countries around the world doing, what is the whole purpose, how's all this fit together. It's very exciting stuff. So stay with us as we visit with Dr. Linda Kai, UT geology professor and involved in the NASA Mars mission, lead co-investigator. So stay with us. This is More Living with Jim Brogan here on News Talk 98.7 WOKI.
You are listening to More Living with Jim Brogan. During the week, Jim is a financial advisor, an author and speaker with an MBA from the University of Tennessee, who specializes in helping people in or near retirement plan for the next phase of their lives. You can reach Brogan Financial during the week at 865-862-6800 or on the web at broganfinancial.com. And now, here's Senior Market Advisor Magazine's 2011 National Advisor of the Year and host of More Living, Jim Brogan.
Welcome back to More Living here on News Talk 98.7 WOKI. I'm Jim Brogan, your host, and we're visiting, it's exciting. We're visiting with Dr. Linda Kai. She's a UT geology professor. She's also lead co-investigator on NASA's Mars 2020 mission, and it is so fascinating to look at origins of life and creation of the world and all these things. I love that stuff. And it's fascinating to just think about the things beyond here on Earth. Dr. Kai, my understanding is the rover launched on July 30, correct? Yep, end of July. So how long will the journey take before the rover touches down on Mars? We will land on February 18th in 2021. See, that's so it takes about 8 months. Yeah, it's so crazy. You've got the time. That specific day? That's amazing to me. Now, in fact, there's, and I didn't know this before we were researching for this show, and it makes sense, but there's actually kind of a narrow time window where you have to be able to launch in order to land under the... Can you walk us through the time window and how important that is? And my understanding is COVID-19 almost made you postpone this project for what would have been over 2 more years.
It would have been 2 years, and so we were fortunate in that we were sort of the mission that really needed to get off. So a lot of people around the country and around the world, despite COVID restrictions, worked really hard to help us launch when we needed to. Yeah, so let's just think about the solar system for a second. We have the sun at the center, and we have all of our planets orbiting it. But they're all orbiting at different rates, so the length of their years is different. And it means that there are only certain times where the planets are actually relatively close to one another. And so when we want to go to Mars, what we want is to get there as efficiently and as effectively as possible. And so we want our planets to actually be on a path where they're actually getting closer together when we launch. And because of the size of the orbits, the Earth's orbit and Mars's orbit, which is substantially bigger because it is further out from the sun, it's about once every 2 years that we hit the right sort of arrangement of our 2 planets to make an effective launch. And so you really want to keep that window. And there are a lot of things that can throw a wrench into the timeline. Part of it is getting all of the equipment ready. Then the equipment has to be shipped down to Florida, and it has to be cleaned. It goes through a lot of different cleaning procedures to make sure that we don't accidentally bring life from Earth to another planet. Imagine the kudzu of East Tennessee being transported someplace else.
I never thought about that.
And then it all has to be installed, and, there's so much testing that goes on, and the launch vehicles also have to go through all of their testing. If you just imagine all of the wires that are involved in any sort of a robot. If just one of those is a little bit loose, that could end your mission.
Sure. The science is incredible.
People worked really hard.
Yes, absolutely. Now, in fact, there's 2 other countries, too, that have recently launched missions, I believe, the United Arab Emirates and China, correct? So all 3 of us. Now, how much sharing is there between the 3 countries on something like this?
Well, I think if you look at our recent rovers, both Curiosity and this upcoming Perseverance rover, we have a lot of collaboration with the European Space Agency. We have instrument teams from France, from Spain, from Norway, on the Curiosity rover from Russia. So there's a lot of help and actual collaboration. In terms of other countries, it's politically not what we do as Americans. We don't work closely with China, so they're really developing their own program. The UAE also developed their own program, but there still is quite a bit of support because it is European nations and the Americas that help run what's called the Deep Space Network. And this is essentially a number of satellites and other things throughout space that retrieve signals. And so on our current mission, the Curiosity mission, we actually stood down for 2 days when the United Arab Emirates was launching to essentially give all of the bandwidth from all of the satellites in the Deep Space Network to them to help support their launch.
We're visiting with Dr. Linda Kai. She's UT geology professor and co-lead investigator of the Mars 2020 mission. It's just fascinating. Dr. Kai, when you want to send a message, like talk to us about the communication between the rover and us back here on Earth. I mean, what is the timeline for that? How long does the message take? And how long does it take for you to receive an image?
Okay. Well, probably the easiest way to think about this is thinking about first, second, and third shift workers here on Earth. And we basically, the scientists and engineers on the mission, allow the rover to have the first shift. So the rover's working during the rover's daytime. And then we sort of work around that to make sure that the rover has instructions. But we always need to remember that, it takes about 15 minutes for for information to get from Mars to back down here to Earth. And so there is a big lag. That lag is mostly important during landing.
Yeah.
Because that's when we need the immediate communication to see whether or not things are going wrong. From the Curiosity launch, there's a YouTube video that I think everybody in the world should watch. It's the most dramatic, 10-minute YouTube video you'll ever see, called 7 Minutes of Terror. Because by the time it takes 7 minutes to get one of these landed missions from the surface of the Martian atmosphere down to the surface. But it takes 15 minutes for that information to get back to us on Earth. And so by the time it's landed, we don't find out for another 7 or 8 minutes.
Yeah,
and
that's
so
crazy.
It's hard to envision how dramatic that can be.
It's hard to imagine how you would land something like that when you're not getting that instant communication or feedback. That's wild to me.
I think people that do artificial intelligence and people that build the robots, and they are the most astounding engineers on the face of the planet, because they can essentially make these things run autonomously for short periods of time to do what needs to be done. But once you're landed, then it's a lot easier because nothing is immediate. Nothing has to be done immediately. And so we have stand downs. We acknowledge that there are federal holidays where a lot of our federal workers are not working. And so, we will plan 2 days worth of activities at a time, or sometimes 3 days worth of activities at a time. And then the rover will just go about and do those when the time comes. And so I don't even think about the time lag in terms of getting data back. We tend to get data back in different forms. We first get, particularly for images, we get what are known as thumbnails. And these are just tiny little images with not many pixels. And they're sent down immediately because we can at least see what's going on. But to get the full images, it depends more on who else is using the satellite communications. We have several orbiting satellites around Mars. We have one landed mission, and we're soon going to have 2 on the surface of Mars, and we're all using the same channels to call home. And so we divvy up the amount of space available.
So can you find out, I guess with the more, you get this initial thumbnail picture, but then you get a more, an image with higher resolution. I guess the pictures alone, how much can you learn from the picture versus eventually years from now being able to actually have the physical samples?
Yeah, and this is, as a field geologist, this is probably both the most interesting and the most difficult part of Mars. I was, a good 20 years into my career when I first landed as part of a mission on Mars. And, all scientists have a certain amount of ego, but I thought that I was a pretty good geologist. And I'd spent so much time looking at rocks in different areas of the world, here on Earth, and you learn a lot. And then the first images came down from Mars, and I looked at them and said, I have no idea what I'm looking at.
Oh, goodness.
It was described to me by a friend before I started on the mission that even though we like to call these rovers field geologists, or a laboratory on wheels, that it's almost like doing science through a straw. Okay, so I want you to think here. If I'm a geologist on land, I get in my truck, I go out someplace, You park your truck, and you might have a couple miles to hike before you actually get to your outcrop. But as you're walking, you're not walking with your eyes closed. You're walking, seeing the rocks at your feet and the rocks to the side, and you're seeing the things that you're aiming towards come closer. And you're absorbing all of that information. And I think we don't give ourselves enough credit at how much we actually observe just doing something like walking from point A to point B. But if you have a rover, it only takes pictures where you point it to take a picture. And when it travels, it doesn't have its cameras on. And so you're not actually getting that information from the walk. And so all of a sudden, you're pointed at one thing, and you only see what you're pointed at. You don't see to the left and right unless you told it to take a picture to the left and right. And so you're missing all of that sort of background information that even as a field geologist, I hadn't realized how important it is to interpretation.
That is fascinating. I've got to admit, Dr. Kai, you're very good at kind of explaining. It sounds like maybe you're a teacher and you teach young people who are new to the field. And actually, when we come, we're going to get to our bottom of the hour break. When we come back, one of the things I do want to get into is the incredible opportunities for the University of Tennessee students, because you've been able to involve them in some of this project, I believe, correct?
Yes, and it has been a great deal of fun.
And what an incredible opportunity for University of Tennessee students. We'll also have our dollars and cents segment. The Federal Reserve has announced that they're going to keep interest rates near zero till the end of 2023. What does that mean for you as an investor? And where is the danger to a retiree? Because it could be a tremendous danger. So don't go away. You're listening to More Living with Jim Brogan here on News Talk 98.7 WOKI.
Through his weekly radio show, television news appearances, and adult education classes taught at the University of Tennessee and Pellissippi State Community College, Jim taps into his extensive knowledge and experience to address issues important to living your best retirement. Join Jim every Saturday morning at 9 a.m. here on News Talk 98.7 WOKI, and visit him online at broganfinancial.com. And now, here's the host of More Living, Jim Brogan.
Thanks for tuning in. This is More Living with Jim Brogan, where it's all about living the best years of your life your way. You're listening to News Talk 98.7 WOKI, and it's just fascinating. We're visiting with Dr. Linda Kai. She's UT geology professor. She's also lead co-investigator for the NASA's Mars 2020 mission. And it's just fascinating to learn about things beyond just here on Earth. Even here on Earth, the origins of the Earth and life, and it's just fascinating. We're going to get back to Dr. Kai in a minute. I do want to get into the opportunities for University of Tennessee students. It's really remarkable, and the data that they're collecting or hope to collect from Mars. Before we get back to Dr. Kai, however, it is time for dollars and cents.
Want to be sure you are getting the most out of your retirement? For all the years of your retirement? That's the primary goal of More Living with Jim Brogan and our Dollars and Cents segment, where we provide you with an important financial tip that will help positively impact the quality of your life in retirement. And now, here's Jim with this week's Dollars and Cents tip.
The Federal Reserve announced this week that their intention is to keep interest rates near zero through the end of 2023. That's over 3 years. It's extremely significant. The Federal Reserve typically, they don't give guidance out that far. And there's been several actions from the Federal Reserve that have been really unprecedented to help combat the economic effects of coronavirus and to help buoy the U.S. economy. In fact, what the Federal Reserve is saying about the economic recovery is, believe it or not, through the summer months, it happened quicker than most economists believed would happen. However, the longer term, over the next year or two, so not long term, but over the next year or two, they expect it to be slower than initially expected. So what the Federal Reserve is trying to do is provide guidance that they're going to the markets that they're going to keep interest rates very, very low to help buoy the U.S. economy. And that's good for business. That's good for younger investors. That's good for younger people that want to borrow money for a house. It's good for anybody or any business that wants access to capital because capital is cheap. However, it becomes problematic for a retiree because the bond market is not paying much interest. And, you may have heard me talk about, but you need to understand that bond values and interest rates move in an opposite direction. So there's really only two things that can happen with interest rates. Either they stay at historic lows, which they are historic, or in which case bonds aren't paying much, or they go up, in which case bonds will do even worse. So I think there's a couple of big lessons that I think as investors we need to learn from this. And one is that the long-term implications of this low interest rate environment are tremendous for retirees that need to live on income that, you're now in an income distribution phase of life. You're no longer saving and accumulating money. You're withdrawing and spending money. And that puts a completely different set of pressures and stresses on the nest egg. And what many retirees have done historically to help hedge risk and provide some stability in the portfolio is traditional U.S. bonds. Now, typically you do that through mutual funds. Well, that can be very dangerous moving forward. Yet interest rates are going to remain low for a while. And so even though we're concerned about volatile stock markets, we know that given time, the markets are the best way to get growth to beat inflation. But that's given time is the key operative word there. The second lesson to me is to not be timing or worrying about the short term in the markets. When we invest with at-risk investments in the stock market and other risk investments, we should be investing for the longer term, at least 5 or 6 years out. And trying to time things for what's going to happen this fall or what's going to happen next year is a fool's game. You might be fortunate a couple of times, but nobody's really been successful at timing market conditions over time. That doesn't mean you can't be strategic about opportunities when things happen, but you don't need to be timing things. And if there's one thing the Federal Reserve that we learned from that over the last 6 months is don't bet against the Federal Reserve. The Federal Reserve has shown an extraordinary willingness to do whatever they can to use any tools in their arsenal to help prop up the U.S. economy. So many investors have not thought we would recover like we did in the summer in the stock market, but that just goes to show us that in the short term, you just don't know. Many people are concerned about how the election affects the market. In the short term, we just don't know. In 2016, the economists thought the stock market would correct 10% if Donald Trump won. The opposite happened. We just don't know. So in our financial plan, what we need to be doing is investing for short-term stability so that when we draw income, we can do it from investments that are not sharply down in value in the stock market. And the money we have invested at risk needs to be for a longer term and needs to be more diversified than just U.S. stocks.
That's our Dollars and Cents segment for this week. You can find this week's Dollars and Cents segment and others by visiting BroganFinancial.com.
Do please check us out at BroganFinancial.com. We've got some new videos that are being released, 3 to 5 minute video blogs. I've also got my next class is at Pellissippi State. And it's through their adult education. It's 2 2-hour sessions. It's on September the 29th and October the 6th. So if you're retired or getting ready to retire, this is for you. It's $59. A married couple is $89. You can attend in class with distancing and CDC cleanliness guidelines, or you can attend virtually through Zoom. We're simulcasting, both live, in person, and via Zoom. So you can find out more information at PellissippiRetirementPlanning.com. You can also call Pellissippi at 539-7167. But the easiest thing, just go to PellissippiRetirementPlanning.com, where really my goal there is to equip you to make informed and prudent decisions that can impact the quality of your life. We've been visiting with Dr. Linda Kai. She is a UT geology professor. She's also a lead co-investigator on the Mars 2020, NASA's, it's kind of a mouthful, NASA's Mars 2020 mission. And, when you actually, Dr. Kai, we talked about the imaging that you'll get back, but I'm sure you would be anxious to get your hands on the rocks, on the substance itself. When will Perseverance make it back to Earth, or do you have to go there and get the stuff? But when will it be back to Earth where you can actually examine it?
It is due to get back in 2031. I am due to retire in 2032. Nowhere do I actually envision that I personally will get to work on these samples that we are bringing back. And so I really see as my mission to use my full set of skills to make sure that what does come back are the best possible samples, the samples that are going to give us the most information about Mars. But it's really doing it for the next generation of scientists.
Yeah, I mean, that's something that really I've been fascinated about that's true in all of science is, because of the timelines, a lot of the times you're laying foundation for the next generation. Then they're going to be studying that. Then they're going to be establishing a foundation for the next generation, right? You're always working that far ahead.
Yeah, and that's part of the beauty of science is that anytime you think you solve something, you actually, what most scientists get excited about is creating new questions. Once we've actually answered something, it's sort of like, okay, fine, let's move on. And so it is always working for the next group. And it requires, and it's sad to say it doesn't always work with scientists because, like I said before, scientists don't lack for ego, but it also requires humility because we're going to be wrong about more things than we are going to be correct about in our lifetime and in our research. So, so we just keep moving. But it really is
great,
about building the science.
Yeah, it's that inquisitive human nature that's ingrained in us. When we come back from our final break, we are going to talk about the involvement at the University of Tennessee and also some of the newer science in terms of the technology that's been able to develop to make the Perseverance more effective than previous rovers that have gone to Mars. So stay with us as we visit with Dr. Linda Kai, lead co-investigator for the NASA 2020 Mars mission. You're listening to More Living with Jim Brogan here on News Talk 98.7 WOKI.
Thank you for listening to More Living with Jim Brogan. If you miss any of today's show or want to listen to it again, visit BroganFinancial.com, where you can access the podcast and other educational materials to help you in your journey through retirement. And now, here's Senior Market Advisor Magazine's 2011 National Advisor of the Year and host of More Living, Jim Brogan.
Welcome back to More Living here on News Talk 98.7 WOKI. Check us out, BroganFinancial.com. Click on radio. You can listen to all of our radio shows really from the last couple of years. They're all podcasts there. This show, if you've missed part of it and you really just want to hear the whole thing, we'll have it up by Monday or Tuesday next week, probably by Monday. I'd urge you to check it out. It's just been fascinating to visit with Dr. Linda Kai, lead co-investigator for the Mars 2020 mission. And Dr. Kai, we talked about, the samples will hopefully be back by 2031. How are you going to get the samples back to Earth?
Okay, so, this is actually quite difficult because the one thing that we haven't done in the scientific community since the moon landings is we have not taken off from another planet. And that's a whole new technology that we've essentially lost. We have the technology that we used in the 70s, early 70s, but we haven't used it since then. And so what our rover will be doing is finding samples, taking all of the pictures we need to give them context, and drilling samples and sealing them in these plastic tubes that will then get put underneath the rover. And then they will be let loose in a cache, and another spacecraft, which will probably have an orbiting version as well, will come land, pick those up, and then bring them back into orbit of Mars, and then another spacecraft will bring them back to Earth. And I'm afraid that I can't actually explain it any better than that, because I don't know exactly how it's going to work.
Well, and who knows the technology where we'll be in 11 years. I mean, I'm sure they'll be developing it even more. The moon, I guess, is, when we think of gravity, is what, 1/6 of the Earth's force size? What is Mars? How big is Mars? What's gravity like on Mars compared to Earth?
I would have to look up the number for what Mars is, but it is substantially less. Mars is a smaller planet. Its diameter is just short of half of what the Earth is.
Okay, that's fascinating. Let's talk about UT students. How have you been, what an extraordinary opportunity for the students at the University of Tennessee. How have you been able to involve them in this experience for their learning?
Yeah, I am a teacher, and part of the reason why I love UT so much, I came from high-powered research schools, but I love a big flagship state school where I can still do the research, but where I have a lot more contact with the students and the teaching.
Yeah, and I want to mention that, Dr. Kai. You got your undergraduate from MIT and you got your PhD from Harvard, right?
Yep.
Yeah, now you're at UT teaching. So anyway, go ahead.
Well, hey, when I interviewed, I was interviewing for lots of jobs, back before I got this job. I left my interview at UT, and I was living in Missouri at the time, and all I could think as I was flying back to St. Louis and driving back to Columbia was, I hope Tennessee offers me the job. I hope Tennessee offers me the job. I loved this area. I loved the school, and I felt that it would be home, and it has been for the last 22 years. So
is it the combination of the research and the student interaction?
It really is. It really is. My research will never go, as quickly as, some of my cohorts that are at more high-powered schools, but that's okay. And I really do get, I get more joy out of helping students than I do out of anything else. And it's from the introductory students who have no idea and are afraid of science to actually realize that they can learn things, and watching other people go on their way. I was so excited this past year. I had a PhD student finish, and she is now working at NASA's Jet Propulsion Labs. And she's working every day in these missions and having such a wonderful time.
Yeah, well, you're impacting lives of young people. Hey, Dr. Kai, we just have about 20 or so seconds. How can people follow the progress of the Mars 2020 mission in your research?
This is going to be really easy because NASA has so many different websites. And if you just Google NASA and Perseverance or NASA and Mars 2020, it will get you to places where, as the mission lands and continues with its groundwork, there will be pictures, there will be data that will be available. They have a lot of exercises for secondary school teachers and primary school teachers to help get more younger kids interested in space. Google is your best friend, although you do have to be careful because there's a whole lot of people out there in the world with nothing better to do than to look at these images and find aliens.
Dr. Linda Kai, thank you so much for tuning in as you've been listening to Talk 98.7 WOKI.
The views expressed by Jim Brogan and his guests are not that of Cumulus Media. Any discussion of financial, legal, and tax planning strategies is not intended to be individualized advice and is general in nature. Always consult with your advisor for advice specific to your needs. This program's content does not represent a recommendation of any particular security, strategy, or investment by Jim Brogan or Brogan Financial Incorporated.